CERT class. I'm Cadet Niven, class 2025, company I2.
I'm Cadet Chang, class 25, A1.
I'm Cadet Wasserman, class 25, company C4. And we are presenting Project 2 on counter-drone weapon systems. And so the problem we were given for this project is to design our counter-drone weapon system, and then to calculate the costs of the effective system, and then to try to sell the system. So we broke that into part 1, 2, and 3. So part 1, we are choosing a design for our weapon system. So the first design that we were given was a cluster of 5 bullet-looking things, are like all brought into one projectile. And so we were given the surface area as 2.49 meters squared, and then using formulas given to us, we made a triple integral to find the volume of our projectile, and we got 0.0942 meters cubed at a production cost of $359.77. We got that production cost by multiplying our total volume by our unit cost of volume, which is $620 per meter cubed. We multiplied that by the volume, and then we added that to our surface area, which was given to us, multiplied by the unit cost for surface area, which was $120 per meter squared, and we multiplied those two and then added that to the cost of volume for the total production cost. So we did basically the same thing for each projectile. So projectile 2 is this like bulbous barrel shape, and we were given a surface area of 1.57 meters squared. Once again, we found the volume using a triple integral of equations that was given to us, and we got a volume of 0.983 meters cubed. Once again, we used our given unit costs to make the total production cost of $799.50, which is the most expensive out of all 3. Lastly, we calculated the production cost of projectile 3, which is the hourglass-shaped projectile. So we were once again given the surface area. This time it was 2.8 meters squared. We once again used a triple integral to find the volume, which was 0.0445 meters cubed. Did the same thing to get the production cost, which was $365.07, which was the second most expensive out of all 3.
Alright, so part 2 deals with designing our projectile in a way that fits the parameters given to us by the government. Hire requires a 70% kill rate of drones by the platform that we choose. Projectiles that detonate within 3 meters distance from the drone are a guaranteed kill. Therefore, we need 70% of our projectiles to detonate within 3 meters of the drone. So this is a joint density function. It maps the probability of the drone landing somewhere in relation to where the projectile is going to land in relation to the drone's location at 0, 0. So you see it's highly concentrated around 0, 0 right on the drone, and drops off in probability as you get further from the drone. So imagine drawing a ring with a radius of 3 meters right on top of this, and we need the volume under that, within that ring, to be 0.7, because the area under this curve is 1 and it's all positive values. So given this, we found that a standard deviation of 1.93 meters off the target produces a projectile that destroys the drone 70% of the time it is fired at it. So once again, 1.93 meters is our golden number for the standard deviation off target. So our standard deviation, how we can lower that and make sure that our drone is more accurate, is by spending more money on our projectile and launcher respectively. So once we control for standard deviation, we were able to derive a formula finding projectile cost, or finding launcher cost based on projectile cost, holding our standard deviation constant at 1.93 meters. That formula is projectile cost equals $2,613 minus 2 times whatever our launcher cost is going to be. So plugging each projectile cost we found in part 1 into this formula, we find system 1 is going to have a cost of $1,893 per launcher. System 2 is going to have a cost of $1,014 per launcher. And then system 3 is going to have a cost of $1,883 per launcher.
All right, so now we're going to get into part 3, and that is all about maximizing our profit. So to maximize profit, we're going to need to determine which projectile and launcher, and so we ended up choosing the very first option, and then we also need to determine how many projectiles and launchers we're going to actually build. All right, so this is our equation, which models the single sale of a combination or batch of 25 projectiles and 1 launcher. So each potential launcher needs to be accompanied with 25 projectiles, and so every, what we call a unit, or every batch, is going to include 25 projectiles and 1 launcher. And projectiles are going to be sold at 600 each, and then each launcher will be sold at 1100. So as you can see, system 1 gives us a single batch or single unit profit of $5,211.95. Compared to the rest of them, that is the highest, so that's the system we're going to go with. All right, so now we're going to get into our costs. So this is our cost function, which is going to be costing us $1,893 about per launcher, and then for projectiles it costs about $360. And then we're given $200,000 to produce our very first batch and our initial startup, and so using that we can create 18 launchers and 450 projectiles and sell those, keeping in mind that we have to have 25 projectiles per 1 launcher sold. Overall, this gives us a total cost of $195,983. So, in summation, with System 1, our gross profit is going to be $289,800, and our cost is going to be $195,985. To get our total profit, we're just going to subtract our costs from our gross profit, and that leaves us with $93,815.
Sir, class, this concludes our brief. Are there any questions?